Hi again, welcome to the Garage Pierre. This time we'll be killing two birds with one stone. Whoever has to evaluate uh, caliper, just there are methods to do it. Like you got the functions to evaluate, you got the aesthetics, you got the the how it works, just the how it is slide or whatever. But you also want to have precise evaluation of the measurements according to the manufacturer's spec sheet. Is it written specs or is it, let's say, out of specs? Is it a pass or a fail? So there's a method which is universally accepted as the ASME method for measuring the let's say the tolerances of this, and as close as you can stick to that measurements or standard, you can have more accurate measurements. We're not going to do anything certified today because we're not a certified lab, but at least you get a decent idea of how your tool is performing. So by killing two birds with one stone, it is Banggood semi this, I'd say, rather nice looking tool. It's 150 millimeters, 6 inches. Nice digital caliper, sorry. Some of the things that were sent with it is one battery already in the case, 2 extra batteries. I hope it's not a sign of early failure, but I don't think so. I've been using this for a month. It goes off automatically. No sign of a weak battery or anything just yet. Everything seems pretty fine. I would have to undo it and measure the, let's say, asleep consumption, but I don't think it's what we need to do. It comes in a nice black low case, instructions and specifications. It comes with the sheet. Like I say, it comes with 2 extra AJ13 batteries, which are very common. Desiccant. Okay, so on for the useless stuff, something that you don't need in the shop to measure. So next step. What are we looking for when we measure something like that? First, we're going to be looking at smoothness of the glide bar here. You know, just use your fingers. It's a good way to determine how smooth the surface can be. You can, after that, you slide the tool, the carriage on the slide bar. That's relatively smooth for a low price tool. I like the feel. It goes good. Also, you're going to be looking at the jaws inside here, how clean it is, how regular the grind is. You're going to be looking at lights. You put that in front of a light, the gap here, and you look if it passes light through, and if it's regular, it has to be, let's say you see no dents or whatever. That's something we'll be measuring a little bit later, but visually you can do a pretty good test on that. Also, one other thing you'll be evaluating just by the looks with the light passing through is the inner measurement jaws here. If you look at them at an angle like this here, you'll be noticing that you see a light gap. But if you get very perpendicular, to the axis here, you'll see that the gap will just get very near zero. So if it's regular, if it's nicely done from bottom to top, means you have a decently made tool. Also, the size numbers. That's a nice nice display, nice big numbers. What else? On the digital display, you have metric, which is the 90% used standard around the planet. You also have imperial numerical, which gives you thousandths of inches up to there, and this last digit here will switch from 0 or 5. It's only like half a thousand resolution. Also, you got the next usage on this is practical for imperial. Naturally, it's imperial fractional measurements in 128 resolution on the maximum resolution scale, and you're going to be having like 64. You're going to be having let me get the other numbers. 30 seconds, 30 seconds here. You're going to be having 3/8 of an inch. Let's say you can have let's say we get to 64, we'll be having a 1/2 inch. This is practical. Some machinists still work with these kinds of measurements. I'm not very fond of this, but some will like it. And a nice feature about this fractional, lots of imperial woodworkers will use this fractional way of working, because woodworkers are most likely to use this option. So it might be a very nice add-on to their toolbox, because that will be the same price as any fractional tool, and it includes all the other modes also. So that's a nice thing to have. Some of the you got 4 features you can measure on this. You can measure outside measurements, diameter, or just whatever it is. Here you go. And you'll be measuring inside measurements also. I'm not very calibrated there, so don't rely on the numbers. I'll be yielding. There you go. This measures in internal. It will also measure depth. If you use this tang here, you can measure depth pretty accurately also. And you'll be measuring step if you use this this feature, which is right here. And let's see how deep something is. There you go. Lean that there. And you get your measurement. So 4 standard features, and everything seems to be in normal, by the looks, it seems okay. But now let's go to the serious stuff and make the measurements on this. The first feature we want to measure with this tool, in order to determine how good it can make measurements, is to determine if there are defects or how parallel are those 2 surfaces there of the jaws. And you also had to look at it, like you say, how polished or how nice they would be. So you put that. This is the shank of a broken end mill. Very regular round surface. So I'll be using this to get around. You got to learn how to apply constant pressure and control pressure onto your tool. This is something you have to learn. If you go into the being a machinist or having to learn parts or whatever with high precision, that's something you have to master by practicing against known references. You get good at it, but it takes a while. So there, I'm going to be zeroing just to make sure that we're starting with a good reference. I'll be measuring from this part of the jaw down to right at the tip, always maintaining that pressure there very constant. That's important. And feeling here, is this holding the same way from one end to the other? Which here, I mean, it seems parallelism seems to be in good order there. There's no movement on this part there, so that's good. So we'll be saying that parallelism is a pass. So now we're going to put this tool to 0, just reset it with the proper pressure, making sure again just not to forget that the jaws have to be clean, have to apply the normal pressure that I would normally apply when I work, trying to be as constant as possible. Reset this to 0, and we'll be doing the test. First test will be 450 thousandths of an inch, and see how we get. I'll be noting the on the pad. I'll be noting the differences or the results according to the reference. To make a proper measurement here, we'll be measuring with the proper pressure applied, and the gauge block has to be in that direction, like perpendicular. Not, you're not measuring in this way here. You're measuring in this direction here. The same pressure I had when I applied my 0. That 0 reference is not going to be reset along all the tests up to the end. So we're 449.5. So we're 5/10 under. Let's make a note. Minus 0.0005. 5/10 under. Now we're going to the 1 inch gauge block. Again, same procedure. Open up, close on the here, always maintaining the same pressure. We're That's pretty good. That's pretty much dead on. And you have to resist to the temptation of applying the pressure to get the reading you want to get on this thing, because it's not what you don't wish for a final measure. You get the real final measure. So this one here, plus minus 0. Let's go for the 2 inches now. 2 inches. Where is it written? Yeah, here we go. Written here, 2 inches. I'm not sure if very visible. Yeah, I think we see it a little bit. There we go. Same thing again. Same direction. As you go higher in measurement, you have to do some wiggling a little bit to make sure that the directions, like the measurement is very perpendicular and parallel. There we go. We are getting half a thousand under, just by wiggling around a little bit there. The pressure I apply always the same. There we go. We're 5/10 under. That's pretty good. This is another pass. Minus 0.005. Okay, let's go for 3 inches now. 3 measurements will be good enough, but we'll make 4. Make sure this is clean. There we go. Checking this again. So 3 inches. Always perpendicular with the jaws. There we go. We are half a thousand under. That's another decent measurement. There we go. Just with the right pressure, maybe go along a little bit. It varies a little bit, but to that zone, if we go to the middle there, we're a little bit off. Like we're from half a thousand to 1,000 under. Let's say we'll rate it about minus 1,000. There we go. Now for the last outside measurement. This is a stack of gauge blocks I made, and this is 5 inches. This is more complicated a little bit here. You have to make sure, as you go higher in measurements here, you have to make sure that you get the right measurements. You'll be probably wiggling around a little bit until you get the smallest possible reading on this. There we go. I think we're getting the nice, a nice stable measurement here. It is 5 inches and 1,000 over. That's right. This is plus 1,000. Okay. Next set, I'm always going to be using the same reset as before. I'm not going to re-zero this tool again. This is still good. We'll be doing some inner measurements now. Let's start with because these jaws here are not perfectly like a razor sharp ends. There is a little bit of a round, not a round, but a flat on top. So I'll be using this 200 thousandths measurement to see how about it behaves in there. You can't go very deep, but oh, surprisingly, whoa, that's not too bad at all. You have to do a little bit of pulling, about the same pressure that you put in, you exert it as pulling pressure now into the tool. It varies a little bit, but it's very close. I mean that this is that impresses me. Even the good quality sometimes are not that close, but it's 199.5, so we are 500,000. We're half a thousand, sorry, underneath the measurement. So the $200,000 is minus half a thousand. I'm left-handed, so I'm having problems to, the angle there is different from right-handed people. Okay, let's go with the, normally you can make 2 of those, but we'll make three readings. This one here is 350 thousandths. There you go. And those are calibrated. Okay, what do we get here? I'm pulling slowly on it. Okay, that's about the right reading. We're getting 5/10. Yeah, 5/10 over. That's a pretty good measurement there. Let's write it down. It is plus 0.0005, half a thousandth of an inch. And we'll make one something under 2 inches, between like, let's say half inch and since I have a 1.4, almost 1.4 calibrated ring here, let's see if you get smaller like this here, by playing with it like this direction, it's not going to give you the right reading. Just a sec. Let me get it started again. This gets delicate there. Okay, you try to get the largest point, and I think this is as good as it gets. It's yeah, wiggling a little bit. It's 1.4, half a thousand over, which I think is a great measurement. Plus 0.0005. Half. That's good. Now, let's measure step with this. Just like before, just clean this up, make sure. I haven't reset it again. It's got to be stable till the end of the measurements. And here, this is the little, this comes from Tom Lipton's little mini granite table. We'll be measuring the step, this feature at the end there, and we'll be using a 1-inch gauge block. Make sure this is clean on both sides. Table is clean. Make sure this is also clean. There we go. A little bit more complicated, but we'll manage. There we go. I'm holding everything very stable on the if I had a wider block here, maybe it would be preferable, or maybe use it in the other direction, but I'm stable there. Everything is perpendicular and parallel and everything, and I'll be getting this down there. Okay, I haven't seen the reading change at all. So this time we're getting 1 inch and half a thousandth over, which is another great reading. Okay, the step is going to be 0.0005, and it's plus. Now the depth measurement, we'll be using about the same principle. The only thing is it's a little harder to hold. Now the problem is to hold the whole thing very stable in this direction and this direction. Okay, I think I got a pretty good reading here. Okay, what does it say? We're half a thousand under, which is another nice reading, I would say. So this minus 0.0005, half a thousand under. Okay, this is let's say some unknown tool, and you want to know if this is appropriate for your use. This is the proper way to calibrate and see if it meets the requirements for your use in your shop, and if it also meets what they claim on the spec sheet. So this tool here is a pass. I would say that's with the feature it has and everything, it's a good pass. Good feeling, slides nicely, repeats even there. I haven't reset it for about maybe 15-20 minutes at least that I'm doing this test with the camera moves and everything, and with the proper pressure there, it hasn't moved. So that's stable, repeats, and I think that can make a very nice, very practical add-on into a toolbox. Okay, just a final little hint in here. It's not everybody that's got those rings here, certified gauge rings. They're very high quality, very highly certified. They're 5 digits after the period there, so it's highly accurate, and also circular to certified circular, and also if you can see a little bit the inside of that is very highly polished also. So it's a nice piece, but they're very costly and not maybe spread among people that we would like to. So you already have a set of gauge blocks that you're using to make your proper measurements, and you can have some spare gauge blocks in your set. This is a 900 thousandths. It's just flanked by two random blocks that you just put there. This is a special device to hold them up together, but you can use some clamps and make sure you protect your gauge blocks with proper material not to scratch them. But this is the less expensive alternative to something you already got, and you can make your that doesn't stop you from making your own measurements and certify your own tools.